So in this lesson, we're going to start with differentiation. We're going to look specifically at the product rule. So we should know the product rule by now. If we take the derivative of u times v with respect to x, we're going to get u times dx plus v times du dx. That's nothing new. So what happens if we integrate both sides with respect to x? Well, if we integrate the left-hand side, that's just u times v. That's what we differentiated to get the right. So if we anti-differentiate, we get what we started with, uv, equals the integral of u, I'm going to write v prime just to make writing a little bit smaller, plus integral of v u prime. And if we rearrange things just a little bit, we get integral uv prime equals uv minus integral v u prime. And this, ladies and gentlemen, is what we call integration by parts. So if we can identify an integral as being the product of two functions, u times v prime, that integral is going to equal u times v minus the integral of v u prime. Okay, so that seems awfully abstract. That seems weird. I don't know. Let's do an example here. So here's our first example. We have two parts here. We have 2x and e to the x dx, I guess, technically, or we have 2x dx. But we have two pieces. We want to identify one of them as u and one as v prime. So u needs to be a function that we can differentiate easily, because we're going to find u prime. V needs to be a function that we can integrate nicely, because we're going to find v. I'm going to do this the wrong way first, and then we'll do it the right way. Let's let u equal e to the x. U prime would be e to the x dx. And if u is e to the x, v prime would be 2x dx. If v prime is 2x dx, v would be x squared. And using our integration by parts, we would get that this is equal to u times v, so x squared e to the x, minus the integral of v u prime, so minus x squared e to the x dx. And what you notice here is that this integral has just gotten more complex than what we started with, which means we went about this the wrong way. We assigned the parts of this, the u and the v prime, backwards what we should have. So let's let u equal 2x and v prime equal e to the x dx. So u prime is 2 dx, and v would be e to the x. Our integration by parts says this is going to equal u times v, so 2x e to the x, minus the integral v u prime, so 2 e to the x dx. And now we integrate again. And the nice thing is, this integral is one that I can do. The integral of 2 e to the x is just 2 e to the x, and we have plus c. So that integral that we started with is equal to our next example, y equals 4x plus 5 times natural log x. We want to integrate this with respect to x. So pause the video, and I'd like you to think about what u and v prime might be. Make your best guess. Alright, so the correct selection would be to let u equal the natural log of x. And v prime would be 4x plus 5. Because integrating natural log x, not a pleasant thing. We actually don't know how to do that. And stay tuned because we're going to do it in just a minute with an example. The nice thing is u prime becomes 1 over x dx, so no more logarithm. Prime 2x squared plus 5x. Not v prime, regular v. So the integral 4x plus 5 times natural log x dx equals, using our integration by parts, which is in our formula book, by the way, we get u times v minus the integral of vu prime. So 1 over x times 2x squared plus 5x dx. And that can be simplified to 2x plus 5 dx. And a lot of times this first part, I won't rewrite it every single time just to save on writing because it gets a little bit repetitive. But this antiderivative we can find. X squared plus 5x plus c, of course. And we're subtracting that whole thing. And we have our original u times v out in front here. And there is our antiderivative. Now, as promised, here's the integral natural log x dx. And you're looking at this going, well, how in the world is that going to be integration by parts? There's only one part, just natural log x. Well, actually, there's really a 1 in there. So, u v prime, one of these is going to be natural log x, one of them is going to be 1. Which one's easily differentiable? Well, it'd be silly to put natural log right there because that's what we're trying to integrate anyways. We're going to put 1 dx there. And u is going to be natural log x. I'd say it's a pretty safe assumption that a good strategy to use in this is if you have a logarithm, that's going to be the u. So u prime is 1 over x dx. V will be x. And what are we going to have? uv, so x natural log x, minus the integral of vu prime. X times 1 over x dx. Well, that's just the integral of 1 dx. So x natural log x minus x plus c. There is the antiderivative for natural log. This will be the last example in this video. We'll have a second part to go along with it with some more examples. We're going to take the antiderivative of arc sine x dx. Again, this is one where we're going to have this 1 in here, and u is going to be arc sine x, because we know the derivative of arc sine x, and v prime will be 1 dx because that's awfully easy to anti-differentiate. So u prime 1 over square root 1 minus x squared dx. Okay, so we have u times v, x arc sine x, minus the integral of vu prime. So that becomes x over square root 1 minus x squared dx. And to do this integral now, we need to make a substitution. Since I used u and v already, forget u substitution. I'm going to do a p substitution just to live wild. So let p equal 1 minus x squared, the stuff under the square root. dp will be negative 2x dx. Okay, so I need a negative 2 there, so to balance it out, we multiply negative 1/2. So now we have plus 1/2 integral p to the negative 1/2 dp so this antiderivative, we have 1/2 times 2, and the exponent becomes positive 1/2. We've got our 1 minus x squared in for p plus c, and of course x arc sine x. And cleaning this up just a little bit, we have x arc sine x plus the square root 1 minus x squared plus c. There is the antiderivative of arc sine of x. And this, ladies and gentlemen, is where I shall leave you in this first part. The next part gets wicked crazy and fun.